That's it from me. Drew, over to you.
All right, thank you very much for that intro, Maria. Good afternoon, good evening, good morning, everyone. Sorry if I'm scaring you with the camera there. I just got a new cam and I'm still trying to find the right spot for it. So, yeah, thanks for coming to today's webinar. We're going to be talking about platform engineering, and we're going to be talking about internal developer platforms. And there's a lot of buzzwords that are actually can be quite meaningful. So just to get things going, like Maria said, we do have the Q&A aspect of Zoom if you want to use that. You can just use the chat. Either one is fine. I can't promise that I'll notice necessarily in the moment that you put a question in, but we will. At the end, we will make sure we cover everybody's questions no matter what. If you do want to put, your location in the chat, that's fine. You're by no means required to do that. So let me share my screen. Where my mouse is. All right, so we do have a little bit of a slide deck. I also will be doing a demo as well. So just we will be making this slide deck available to you after the session is over. And if you would like further information, you're always more than welcome to set up a session with one of our field teams that are happy to show you and give you a deeper dive. And we'll talk about that more later. But let's get on with our little slideshow here. Welcome to Humanitec. We're going to be talking about two of Humanitec's products here, SCORE, which is our open source offering, and then our main SaaS offering, which is Humanitec's Platform Orchestrator. Between the two of these, you can build a pretty, I believe the word is kick-ass internal developer platform. But before we get going, let me introduce myself a little bit. My name is Drew Etzel, Andrew or Drew, either one is fine. I am what we call a senior enablement engineer, or a C. I got to make up my title, so I kind of went for a little silly there. At Humanitec, I've worked at such places as Heptio and Mesosphere, if you've ever heard of them. I was employee number 91 way back in the day at Splunk. And believe it or not, I've been working with tech startups and e-commerce since 1999. I entered IT way before that, but I don't want to talk about dinosaur days. So let's move on. All right. So, one of the things we're finding a lot of in working with platform teams all over the world is when you make changes to various parts of your deployment environment. Maybe you change a dependency, maybe you're switching databases altogether. Could be something big, could be something small. Maybe you've updated, maybe you're using a different authentication method now, so you need to update a lot of secrets configurations, or there's a lot of different things that can happen over the course of time beyond the typical code updates. And this is where we're finding a lot of organizations are generating a lot of friction. They're generating a lot of frustration, and they're generating a lot of burnout and extra work. So because of that, because of the relationship of workloads and resources, you're going to, different teams are going to be involved. You're going to have to involve the platform team. They're going to be brought in because, all right, now we need to completely change the way we do certificates because our secrets are, so every time you make these sorts of changes, it can become really, really burdensome for all the different teams. And then the thing with anything new, like, oh, okay, now we have a new version of this. Well, yeah, but that also means somebody has to keep it going, make minor tweaks, do different little updates as well. So anytime these types of changes, they're all going to start to pile up. And at the end of the day, what is all of this really about? what is all this really about? It's really about configuration management. What do I mean by that? Well, let me pop out of my slides here for a second, and I'm going to take you, a typical view of a developer is something along the lines of what you're seeing right here. This is a Git repository. You're a developer. Maybe I'm assigned to work on the user API. I'd be in here. I could be working on my Docker file. I could be doing my edits within here. But then when it comes time to actually run this, if I'm not just running it on my laptop or something, then if I want this to be able to be deployed into dev or staging or something like that, that's even more configuration files. There's probably a sea of Terraform files that are designed to build my dev environment, and another sea of Terraform files that are designed to build my staging environment. So anytime we're talking about these types of changes that you're seeing here in this this very pretty slide, the reality is what you're really doing is you're manipulating configuration files. You're manipulating custom CRDs. You're manipulating Terraform scripts. All of this is what we call configuration management at Humanitec. So and this is where the complexity and the friction and the DevOps breakdown can start to happen, because yeah, sure, one file is fine, but what inevitably happens is it's going to start to grow and grow and grow, and then you're going to have 3 or 4 versions of it, one for each of the different environments you might be deploying to, and you'll see the law of exponential growth turns this into this very scary equation you see down here at the bottom of our slide. 10 services plus dependencies times 4 environments. That's about 30,000 files that are being touched, maybe updated, maybe deleted per month. So, that's just for 10 services. If you've got a large enterprise, you certainly know they've got more than just 10 services. So you start to see the number of little tweaks, little configurations, and things that, humans have to keep track of. So, if the developer isn't keeping track of these files, then the platform team is, or maybe some sad combination of both. The developer knows a lot about the Docker file, and the platform team knows about the Terraform, but inevitably, the developer is going to be troubleshooting Terraform all by themselves because it's 3 in the morning and they have something due the next day. That's the kind of cognitive breakdown, the kind of DevOps burnout that we're talking about. So what we propose to solve this particular issue is to build dynamic configuration management into your development platform. And here's the thing about development platforms. Everybody has one. If you are putting out software, you have a development platform. It may or may not be very well thought out. It may or may not be, ideal, but you do have one. And so we believe that, pretty much any development platform can benefit from automating this configurant management. So putting a robot called Humanitec Platform Orchestrator in charge of your 300 to 600 to 30,000 files a month, putting a robot in charge of that can greatly benefit your team's psychology, so that, the robot is now doing all the tedium. The robot is now doing all the ticket ops. The robot is now, making sure that the right DNS and the right certificate are in staging. So, the robot is less likely to accidentally use the prod password and staging, or the staging password and those kind of normal human errors that happen inevitably when you're doing this type of operation manually. When you turn it over to the robot, dynamic configuration management, that's when you can start to, as I say, automate the tedium, automate the DevOps tedium. And so the way this works, the way the platform orchestrator works is it is going to sit between your platform. So between your Kubernetes cluster and your RDS database and your CI system or your CD system as well. So, and it's going to take the information from your CI system. So your CI system says, I want to deploy the web front end workload. So that's the abstract request. I want to deploy the web front end workload. And then the context, the CI system says, and I want to deploy it to development, or I want to deploy it to staging. Or the CD system says, I want to deploy this approved web front end updated version to production. So the abstract request is what you're deploying, and the context is where you're deploying it to. So your CI system, your CD system provides that information to Humanitec's Platform Orchestrator, and that then Humanitec's Platform Orchestrator is going to take that information and it's going to provide the executable configs like you see here on the slide. So Humanitec is going to say, oh, okay, the web front end, it needs a DNS entry. So here's the executable config for Route 53 to set up the DNS entry. Oh, here, it also needs an S3 bucket. So here's the Terraform script that's going to run to generate the S3 bucket. And then, so that the workload can then connect and use that S3 bucket. So that's the job of the Humanitec's Platform Orchestrator. It sits in the middle and it generates the required configurations for whatever deployment environment you're deploying to. So now, instead of you having to keep track of deployment.yaml.dev and deployment.yaml.staging and all of those other, config files and jumbles of deployment scripts and whatnot, now it's Humanitec's Platform Orchestrator that's doing all that for you, and this is the process and method that it is using. So that's kind of what's happening underneath the system. Let's take a step a little bit higher up, and let's talk about the three different products, moving parts, if you will, that are connecting, your Humanitec, your Platform Orchestrator, to your platform and to your developers. So on the left-hand side of the slide here, that's the connection to the developers. On the right-hand side of the slide, that's the connection to the platform. So over here on the left-hand side, we have this open source offering called Score. Score is a workload specification. So it is a what we call a platform agnostic workload specification. So what does that mean? Well, let's jump out of slides here, and let me just take you into a simple Score example. So I'm borrowing one of our sales engineers gets for this. So if you're wondering who Will Overton is, he's a fellow Humanitec. And we can share, these are all public Gits, so you can take a look at these. But this is an example of a score file, but let me just jump back one level. And so this is, as I was saying before, this is probably what a typical developer might see. You've got your Docker file, you've got your deploy file, your build image file. These are related to your CI system. And then we have this score file And this is meant to be kept along with, the Docker file and the other, the other aspects of your individual workload. And it is here within the score file that the developer can declare dependencies and configurations for your workload, but they don't have to give specifics. So, they can say, all right, this workload needs to have service port and target port. This is the actual container image. It needs to have these key value pairs that you need to be populated so that it can connect to the database. It also has a requirement of a DNS entry, and it also has a requirement for a MySQL server. But if you look here and see, this is very unspecific. It doesn't say Route 53, and it doesn't say a particular brand of MySQL. It just says MySQL. And that's what we mean by sort of platform agnostic. So the idea is your developer just says, hey, this needs DNS. So, if it's running on-prem, it's going to need an entry in internal DNS. If it's running in Amazon, it's going to need an entry in Route 53. If it's running in Azure, it's going to need whatever Azure calls Route 53. I don't remember, Azure DNS most likely. So that's the idea here, is that for the developer, they're not necessarily interested in the intricacies of your staging DNS server or the intricacies of your Azure AKS DNS integration. That's not something they're super that really they should be thinking about. They just know that their workload needs a DNS entry. It's the web front end. That's that's how that goes. They also know that it needs a MySQL database, and it has also this information that it needs to pass to the database. But again, we're leaving that up. As a developer, we're leaving that up to the platform team to actually interpret that and make that a reality when it comes time to deploy. But as a developer, I can come in and I could, for example, add maybe I say, all right, now I also want to add an S3 bucket dependency. So it's just a matter of coming in, and making an edit, coming down here to resource. It's good old, gotta make sure I got that. So then I could call volume, and then type, etc. So then I could make, I'm not going to commit these changes to Will's, but so then as a developer, I could then add in that dependency. Now, one thing to keep in mind, you still have to, even with Humanitec, you still have to talk to your ops team. In that circumstance, you would need to talk to your ops team so that they can make sure that their part of the equation, is managing that. So now let me jump back to slides a little bit so I can talk a little bit more about the platform team side of the equation. So that on the left-hand side, you have Score platform agnostic. It works with Humanitec. It works with Helm. It works with Docker Compose. There are other forks that are being worked on. There are other platforms that are in the pipeline. So look for Score to be more, even more platform agnostic going forward. And like I said, it's been forked. People are using it on their own. Completely homegrown internal developer platforms as well. But an off-the-shelf one comes from Humanitec. And that's kind of where we're going to pick up on the platform team side of the equation here. So I've declared my dependencies. I've got a Postgres dependency. I've got a DNS dependency, whatever I've declared in my score file. And so then it's incumbent on my platform team to set up the recipes, so to speak, for creating these dependencies within Humanitec. So, if a Terraform script is required, you're going to need to let Humanitec know where that Terraform script is. If you just need to talk directly to AWS, to create an S3 bucket, you're going to need to provide some authentication for Humanitec so it can talk to AWS to do that. And that's what these drivers are for. So the other open source part of this are these things called drivers. I'm not a huge fan of the name drivers, but I don't work in marketing, so I don't have a vote. But what the drivers do is they provide the communication mechanism between Humanitec and your platform. So, if Humanitec needs to talk to Terraform, so Terraform can talk to Google Cloud, so it can spin up Cloud SQL, then that's what these drivers are for. If Humanitec needs to talk to AWS because it needs to, set up a DNS entry, that's what those drivers are for. So that's the other side of the equation. And so what the platform team or your ops team is going to be doing is they're going to say, oh, okay, so I know my developers are going to need a Postgres database. I've decided I'm going to be using Cloud SQL on GKE. So I'm going to set up the Cloud SQL driver so that it will, connect to the correct Cloud SQL instance for my developers. And so the platform team sets up these definitions. So then when Humanitec is presented with the score file and the updated container image, it can go, oh, okay, Drew wants to deploy the web front end to development. And I know that in development, we use this Cloud SQL for Postgres, and we use this DNS server for DNS, and we configure our S3 buckets like this. So then Humanitec will go about configuring all of that and then deploying the workload. And then from there, the CI system can, go and run more tests. The CD system can go and seek out approvals. Whatever the next step in the deployment process is, once Humanitec has generated the deployment environment and actually deployed the workload, then your CI system, your CD system, your manual testing system, whatever you got going, that can pick up from there. And you can, do the same thing. If for whatever reason, then it passes all of your tests in dev, and now you need to deploy it to staging, the same process would happen again. Your CI system would say, hey, Humanitec, remember me? Okay, well, we just deployed to dev. Guess what? Now we need to deploy to staging. And so it's the same workload, but the context now is staging. And so then Humanitec says, oh, hey, staging. All right, that's this Cloud SQL instance using this staging database password, using this staging S3 bucket, et cetera, et cetera. So that's the operation that's going to be occurring, and it'll be passing back and forth between your CI system and Humanitec, your CD system and Humanitec, et cetera. So again, and this is kind of the visualization of what I was talking about within within your particular CI/CD infrastructure. So what happens is you make a change over here, you update the code, maybe you update an authentication process, whatever. Like I was saying before, you push that change and to your CI system. Well, first you push it to your version control system. You do git push, and then your CI system is programmed on git push to then provide Humanitec with updated information, and then push the new image if necessary to the registry, and then Humanitec picks up the ball from there. If it generates any resources that might be required or if the resources are already running, it will connect those resources. Then once all of the resources are either generated or connected, and by resources, we mean dependencies here, then Humanitec will deploy the workload. We call this process read, match, create, deploy, RMCD. And so the idea here is your CI system is going to provide, the score file and the updated container image. So Humanitec is going to read the score file. Then, based on the rules that your platform team has set up, it's going to match resources based on the context here. So CI tag of staging. So then it makes those matches. It makes all of the proper matches for a staging environment. Then it creates any of the necessary resources. So if the S3 bucket doesn't exist, Humanitec will create it. If the S3 bucket does exist, Humanitec will connect to it. So either one is an option. And then once everything is created, then finally the last step is Humanitec will deploy that particular workload. So that's the read, match, create, deploy. And so what happens is you get what they call, whoops, whoa, there we go. Let's do that again. What we call a golden path. So again, we've got our dev request, context, environment equals development, that gets fed to Humanitec. So it's going to read the score file. It's going to match resource definitions from the development environment. It's going to create the configurations, and it's going to do the deployment. So, the EKS cluster is configured, maybe a custom namespace is generated, maybe persistent volume claims are generated, maybe, and then it's going to maybe query a secret store so that it can gather the proper RDS credentials for your database. Same thing for your S3 credentials, could be querying secret stores. Then it's going to configure Route 53 DNS. It can also update certificates automatically as part of this process. And then once it's all done, it will then deploy the workload. Another kind of example here is being able to create an ephemeral environment. So let me back up here. There's a lot of builds to back up through, but that's okay. One of the key benefits you get by automating this spaghetti, by turning this pain, turning this tedium over to your robot, to the robot, Humanitec, you get the ability to create what we call, ephemeral environments. So, I want to work in a copy of dev, but I don't want to be working in the main dev environment. Maybe I want to test an updated database, or I want to try using a completely different database, but I can't do that in the main dev environment because everything is configured to use the old database there. And if I go in there with my new database, I'm going to break a bunch of other people's work. So I can create what we call like an ephemeral environment. And for that, because Humanitec, the robot, is able to do all of these things automatically and at robot speed, you can create these sort of ephemeral environments. What before might have been 15 tickets to get a new namespace, to get a new RDS database, to a whole new DNS, all the different configurations that might require tickets, might require you to go get up and buy somebody a coffee just so you can get that new namespace set up on the dev Kubernetes cluster, whatever it takes. All of that can be automated. And then, Humanitec's going to do its thing. But this time, since it's creating an ephemeral environment, everything's going to be brand new. It's going to be creating everything. It's not going to be connecting to anything. Maybe it's going to, it's going to create the brand new flavor of database, everything's going to be completely separate in this ephemeral environment. And one of the really nice things about this as well is Humanitec Platform Orchestrator is specifically designed to delete all of this when you're all done. Like if you run all of your tests on your new database and it's a dud, it's never going to work, then you could go in and you could tell Humanitec, hey, delete this ephemeral environment. Humanitec will delete the namespace. Anything that Humanitec created, it will delete. Anything that Humanitec didn't create but connected to, it will just disconnect from. So, obviously here it's not creating the Kubernetes cluster, it's just creating the namespace. So don't worry, it's not going to delete your dev cluster, but it will delete.
Hey, Drew.
Created. Yes.
Sorry, you're not sharing your screen. There's still score at the layout since.
Oh, let me stop sharing. Something went wrong with Zoom. Sorry about that. I've been on slides this whole time, folks. Sorry about that. Let me try again.
No, just like for the last couple minutes, so it's not the beginning,
okay.
but
All right. Let me see here. Sorry, folks. Let me see. Can you see now?
Yeah.
Is that better?
Yep.
All right. Sorry about that, everybody. Hopefully, I painted a picture with words.
Yes, it was score. Everybody knows what score does.
Right, yes. All right, so, and these golden paths, I'm not going to dwell too much longer on these golden paths. You can see these in the slide decks. For something like this, it's for something that's going to be deploying to production, it's probably not going to be creating these things whole cloth. It's going to be connecting to things. It's going to be injecting things instead of creating them whole cloth in the ephemeral environment. And again, here, I'm going to skip ahead. Like I said, you could add another database and have these sort of ephemeral environments available to you. So I'm not going to spend too much more time in the slides here. I do just want to show a bit more of SCORE and a bit more of the Humanitec UI, and you can kind of see how these things mesh together here. So let me show you what we call our bank demo. So this is it's a made-up bank. I forgot what we're calling it, like Money Bank or something. But this is their their web app. Maybe it could be their phone app. It is a web application for this bank. Log in, check your balance, that sort of thing. And it is made up of 4 microservices. We have a front end, we have a money API, we have a report worker, and we have a users API. So it is made up of these 4 microservices. I've only deployed 3 in my Humanitec. So, but the example here is all 4. But I'm just going to come in here to say like the money API. You'll see we have the SCORE YAML here for our money API. It's got some port information. It's got some typical CPU memory limitations. And then it has this dependency declaration of MySQL. So that's kind of the money API. And I've gone through and I went ahead and I deployed this to Humanitec. So if I come in here to my Humanitec UI, you can see here's my bank demo again. It's got a weird name thanks to Terraform, but you'll see my money API again has been represented here within Humanitec. So you've got money API, you've got these ports, and sure enough, we've got those ports are represented here. Other limit, these limitations. But here's where it gets interesting. So I said MySQL. So I said I need a MySQL database. But then the way my platform team interprets that is actually Postgres, which is fine. They're both that's our version that we're running here in our setup. So the way that happened is my platform team. So if I'm the developer here, I'm working on the Money API, and I say it needs a MySQL database. Well, my platform team, they came in here and they set up this MySQL resource. It's a Postgres resource that is, it's pointing to this particular database that we have running. And it's got, this is the where it's located. We've got the password stored in a secret store. And then we set up these matching criteria such that, anytime something is going to be deployed to a development environment, it's going to grab this particular Postgres. And that's exactly what happened. So, my Money API matched to that Postgres. And then, similar for there's different requirements for my user API. And if I switch over to my web front end, it has a DNS dependency as well as a persistent volume PVC claim dependency that's been reflected in its score file. So and then from here within Humanitec, I can come in and I can deploy my workloads. And again, everything you see me doing here, clicking around, it's not normally the way you would go about it. Normally, it would be a CI systems, CI system doing an API call to hit deploy, and it's a CD system that's telling Humanitec that the last version of the container has been promoted to prod, and now it's ready to be deployed to prod. That sort of configuration. But I do want to show you a couple more things in the UI before we wrap things up. But I just want to show you, the idea of ephemeral environments. I can create an environment, clone it from my current environment, and I could call this, test dev. I can hit create, and then, and so what happened is Humanitec copied the last deployment over to this test dev environment. I can hit deploy here. It's probably not going to work because my Kubernetes cluster is tiny. I run out of, but the idea, so then I could run my tests here in test dev. Yeah, there's, my Kubernetes cluster is full up. I run a very tiny cluster. But then, at the end of the day, if I'm done with this test dev environment, I can also just hit delete, delete that environment. And now, that environment is gone. Humanitec will have cleaned up any of the namespace or any of the other things that you see there. So, all right, one last little bit here, and then we'll jump in to Q&A. So again, the idea is, you're going to be, turning all of the file management, all of the resource management over to Humanitec, so that you don't have to, file 100 tickets to your dev team, or your developers don't have to know the ins and outs of, both JavaScript and Terraform and Kubernetes and AWS. Excuse me, sorry, and AWS. All right, so we did do the demo. We have a couple of tangible results slides here that we can share with you. We also have built these reference architectures So this is kind of an idea of where Humanitec sits in a much larger, very typical system. Not every platform is exactly this, but most platforms are some version of this. You can change the cloud provider. You can change some of the, maybe it's GitLab instead of GitHub, that sort of thing. But the idea here is, this is, Humanitec sits in between, your Terraform and your CI system and your platform, and works directly with your developer, your developer platforms as well, like Backstage, to provide the platform orchestration. One last bit here, and then I'll turn to questions. Like I said, you're more than welcome to get some one-on-one time with one of our sales engineers if you'd like. They can do a more personalized demo for you. If you're interested in Azure, they can do an Azure demo. If you're interested in Google Cloud, that sort of thing. We even have an OpenShift demo. That they can definitely get that going for you. So don't be shy if you'd like to do a deeper dive. With that, let me stop my sharing here and see if we have any questions. Is the screen frozen? Oh, sorry, I missed that. All right. Sorry about the difficulty there, folks. But we will share the slides with you. So.
Yeah, no worries. Thank you, Drew. And to add to that, we have one upcoming webinar with our CEO. I'm going to put it in the chat, reference architectures, deep dive into building IDP on Azure. So this one is GCP. There is one more coming up with Azure. There is also a replay from AWS. So if you want to dive more into reference architectures, I think that's a good place to start in. And Drew mentioned that you can request demo, right, with our solutions architects, platform architects. This would be the best place to do it. I just sent the link also to the Slack, request a demo. And once you submit the form, we'll connect you with our platform architects. They look at internal developer platforms every day. So we'll be excited to look at yours. But I see there is one question. Drew, I'll read it out if you don't mind.
No.
Can I use Score alone for testing without Humanitec? I guess that's number one.
Yep, absolutely. You can. Score is designed to work with Docker Compose. So if you wanted to run it on, Docker Compose on your laptop, it also has an export capability for Helm charts. The problem with Helm charts is that Score is a bigger scope, but yeah, it also has. There are a few private. There are a few private forks of Score. I don't know that much about them. So, but primarily right now, Docker Compose. I know ECR is another one on the list, which is AWS only. But yes.
Cool. Another question, how can I build, test my resource services on pull request before merging? You only talked about deploying them.
So this is where the ephemeral environments that we were talking about could really come in handy. You could, configure Humanitec to, maybe detect a new image that has a tag of test. And then that image, you're not ready for your final merge. You're just ready for some preliminary testing. Humanitec could, build you an ephemeral dev environment, and then that could run those tests and delete that environment, and then do the big merge to do a bigger merge, or do a daily pull request, or whatever, however you've configured it to dev as well. So you could easily leverage those ephemeral environments for just that kind of use case. Absolutely.
Cool. And the last question, how to define my environments? Are they stored in Git?
They can be, yes. So environment definitions are they are stored within Humanitec, but you can interact with Humanitec via the CLI, in which case you can store them in a Git as good old human readable YAML. If you're mainly working with the API, you can store them in JSON. Or you can store them in YAML and then convert them to JSON right before. Or we do have customers that interact primarily with the UI, but you absolutely can store all those configurations in a Git. We have a customer. They have Git repositories for their developers. And then they have a separate Git repository around environments that's primarily used by their platform team. So that the platform team keeps the Humanitec configurations in their Git. The developer just keeps score in their Git. Those are great questions. Any more questions?
As well, people think through questions. I'll make one more announcement. We are hosting PlatformCon in 2 weeks, June 8, June 9, the biggest virtual and free conference for platform engineers, more than 20,000 registrations already. Talks from Brian Fester, Charity Mayors, Nico Watt, real great lineup of speakers from DevOps platform engineering industry. If you guys haven't registered, I definitely recommend it. And and you just thank everyone for coming.
Yeah, thanks again, everybody, for coming. It's been a real pleasure to talk your ear off and pontificate. Hope to see you at PlatformCon, or I'm sure I'll see you at KubeCon if not. So take care.
Yes, and we'll send over webinar replay and slides to everyone tomorrow. So thank you for joining. Hope you have a really nice day, and